And whenever you cannot see the screen, please let me know. So today we'll start up another unit in spatial database and modeling. Okay, that is very important for your GIS applications, especially. Okay, so today topic is, can you see my screen? If you cannot see, please let me know.
Okay, sir.
Can you see?
Yes, sir.
Yes, sir.
So today we are going to study a new topic on spatial decision data modeling, that is web applications for geospatial data dissemination and processing. Last time we already in the last semester we have studied how GIS data sets are created. Now we know how the geo database are created in GIS. Now we have seen how the internet technology and how HTML file is created and how you will be creating it. Now the next process is how to uh, join or link your GIS data set so that it can be linked to the server. It can be on internet so that each and every individual and the users can obtain the information through his mobile, through his laptop. So that is known as WebGIS, a popular term in remote sensing. So we'll be doing and we'll be studying it, how and why it's important. So what are the major influences from GIS? We already have studied but will be revising it. That is, advanced GIS work has influenced significantly by high computing and advanced visualization system. Now, high this GIS technique is very good in visualization. Like in many times, you will see nowadays that in the televisions or in many people WhatsApp status, they were giving the information what Indian Meteorological Department provided them using this remote sensing geostationary satellite data and GIS in conjugation with GIS. They provided how the cyclone will move, what is the speed, what is the time, when it will be the highest, when it will be the lowest. So I was seeing in WhatsApp status that many person who was not from remote sensing background, who were not from GIS background, who were from Sanskrit, who were somebody was from anthropology, somebody from Hindi, but they were using that web portal for visualization, for representing it, so that all the persons who are directly or unconnected to them can obtain that information, and the information can be segmented and can be scattered in real time. So GIS has quickly incorporated distributed system and database for interoperable solutions. Nowadays, each and every operations of the government of India, whether you talk about Namami Gange, or whether you talk about water resource management, watershed management, smart cities, then forestry applications, forest cover mapping, land use, land cover mapping, all are being made and being created using GIS software. So microcomputer has allowed GIS to be applied in new and improved GIS education. So you can see that now the GIS is more popular in each and every portions. They are using Google Earth, they are using Ola, Uber, that uses the GIS operation. So the portability, the use of GPS, using all the accuracy related to navigation has popularized this subject. Now, we already have studied in the last classes that how World Wide Web, that is WWW, and high speed network access has given a new dimension to geospatial domain. Like if today I want to know anything about Maharashtra, the geology, the geomorphology, the soil, the land use, the water table, the systematic investigation. If I want to go, I can directly go to Bhuvan, or I can go to their regional remote sensing site, and there I can fetch the entire information, and that is possible only because of this high internet speed. Because for doing any kind of GIS operations, especially the web GIS, internet is prerequisite, as well as a world web is required, that is www dot. So what has it given? It provides large data sets can be processed. So if I've got a database related to the entire city or entire India, related to soil, geology, geomorphology, that is a huge data set. And for that, a GIS is the only solution which can handle the data, which can provide the solution. And more complex model, as with the advancement of GIS, as with the other subjects, is it has now become more decision making. It has become more popular. It is more having more visual aids, visualization. It has been more simplified, so that a unknown person, a villager, a farmer, my father, who is also not a technophobia person, can easily understand the map, can easily understand those information that the government of India or the other agency related to research and development are trying to broadcast, can be done. So, what is the advancement of interactive communication technology leads to new trends in GIS technology? So that has provided a new dimension. Now, any data set from USGS, you're fetching it, you're downloading the satellite images, you're downloading the precipitation data, you're downloading the temperature data, all the data you're downloading it, and that is possible because of information and technology. You're downloading list 3, list 4, landsats, sanital, all the data you're downloading it. So how is it possible? It is all possible because of internet access, high internet access, the use of interactive communication technology that has created a new dimension to the field of space science. So what does it does? It provide trend towards the open system architecture. So right now you can see that nowadays open source softwares are more popular in nature than the proprietary software because of the licensing issue. Then moving from simple description and query system to simulation and modeling. That when we started, we were more focused on creation of database, but generally we were not doing any kinds of simulation based modeling or some prediction modeling, or we were not generating an early warning system. So now all these same are based on simulations, and you can predict before any natural disaster is going to happen, or we can predict what can be the rainfall pattern, what is the production, crop acreage estimation, yield estimation. So nowadays it's very population popular in agriculture department too. So real-time data integration and development of symbological models based on logical relationships in the form of statistical form. So right now, if there is a disaster because monsoon has started, so each and every state is going to face a huge amount of runoff that will be generated during this monsoon period. So this remote sensing and GIS can provide you the solution to which are the areas which are at a higher risk in case of high rainfall, so that we can communicate to those persons that please vacate the area in case that within this is the amount of rainfall that is predicted for the coming 2 to 3 days, and if you stay at this place your life is at danger. So what we do, the NDRF or NDMA team suggest those persons to go and have a shelter that is safe provided by government of India. Then integration of multimedia data into GIS platforms, that we are always doing it in our day-to-day exercises. And now it's very popular that inclusion of artificial intelligence like fuzzy logic, expert system, neural network. These are very popular subjects, techniques that are being used in GIS. And finally, semantic wave and precursive computing. So, what does geo information services technology does? How it works? So, first we'll be reading about GIS. We have already seen how GIS is interdisciplinary in nature than the traditional subject, where a lot of computer science is related, where the MIS is created, the graphics, the visualization, the database management system, the administration, the security, the programming. So means a lot of computer science is involved. Then on the other side, you can see that this is the same in GIS. You are going to correlate the cartography, geodesy, photogrammetry, landforms, spatial statistics. Means a lot of geography, geology, environmental science is involved. And finally, this both computer science and the geography and the GIS is applied for any public administration or planning, whether it's any kind of planning, whether that is cadastral planning, land use planning, urban planning, forest planning, geological planning, mineral exploration, forestry, site selection, marketing, civil engineering, criminal justice, surveying. So you can see that how this GIS, computer science, and geography, whatever comes to your mind, that has got an intervention. So now, when you have got this much of data that you're going to handle, so there must be a architecture, and in that architecture, there must be a component who will be handling the data sets. So what we started, how we started. So we'll start off with an information system where we'll be providing the decision support system to the decision makers. Then we'll be handling the data management. When we are talking about remote sensing and GIS, the data management, what we are talking about is the data known as spatial data and non-spatial data, or it can be a raster data or vector data, whether it can be a spatial model or non-spatial model. All the data sets what we have already studied and discussed will be managed through knowledge-based management system, or you can use the various dialogue management system, whether that is an attribute based query that you are going to query on the basis of attribute, or that is a report, or whether that is a special query, whether that is a non-special query, will all will be attributed to your attribute data and spatial data. So this is the external and the internal data that we are going to provide, and finally on the basis of this spatial data and the non-spatial data, all the solutions will be given to the decision makers, and these decision makers on the basis of all the database that are saved or archived in the server will be used for creation of this information system. So the major component of the entire mechanism that we have discussed right now will be classified into the following unit. First is database server, that is database management. So what we have to do, we have to create a server. Parallelly that server will be managing that database. Then secondly, application of server and application of software. The second operation is where you are going to apply, what is your application, what is your objective, what is your outcome, and for that you will be requiring a software, because until unless you don't have a software, you cannot come to a decision. And finally, that software has to be installed in some hardware. So we, this is near about the same component that we have already discussed in GIS, the basics. The only difference is database server and application based server that has to be created for the management of database. So how does it works and what is it's going to do? So this is the network based geoinformation services that the government of India or any organization is trying to build, or what where GIS we are trying to build. The first one is GIS server, where we'll be using all the database will be there stored, whether that is a spatial data, non-spatial data, raster data, vector data, satellite images, all the data sets will be in your GIS server. Then there will be a VIS web-based application. There will be a interface like what you want to check, whether you want to see the village boundary, district boundary, population, forestry, land use category, what you're trying to search. So all the things will be saved in this web based application, and the user, the web client, it can be a client or the web user, anybody from Uttarakhand, anybody from Srinagar, anybody from Rajasthan, anybody can anybody from soil science, anybody from forestry, anybody from architecture, anybody from urban planning will go and hit to the waiver or the wave application, and on the basis of his questionnaire the exact response will be fetched from this GIS server, and using this web application again it will be sent back to the user. So this is the three operation through which a command, the questionnaire, is being used, is being fetched from the GIS server in between with the help of web based application server that can also be say as a gateway. So how does this gateway and web-based application server works up? So this is a network-based geoinformation services. So what we will be doing it, we'll be creating a data server. The data server is more kind of a server where all the data sets are saved. Just like it, if you are using an internet, you have created a Gmail or Yahoo Mail, and they have provided you 25 MB size or 30 GB as a Google Drive space. So where is that space or the data what you are uploading it or downloading it save? So that is going to the data server that your operator, whether that is Facebook or Instagram or Gmail or Yahoo Mail, has uh, buy it, and then he provides the space to each and every user. Right now, the space that has been provided to each and every user is a free space. No charges are accounted for it. But if you go for a license version or you go for a business version, a large amount of, oh, oh, whether I am recording it?
Yes,
Yeah,
sir.
okay, okay, I'm recording it.
Yes, sir.
Otherwise, again, I had to take the entire classes if I forgot. So from tomorrow onwards, if I forgot, please do let me remember that my slides are recorded. The slides
Okay,
are
sir.
moving. The slides are
Yes, sir.
moving.
Yes, sir. Yes, sir.
Okay, okay. So you need a data server, then you need a GIS or a map server where you will be doing on creating all the maps, and finally all the applications will be sent. Then you need an application server where all the applications will be dealing with will be fetched from your data server, and again you need a web server where the user that is browsing, whether that is a client or a web client or a user, will put a request to the web server, then the web server will go to the application client, the application will client will provide the data from the data server, then the entire operation will be handled up. The entire reports and the maps have already been uploaded in your server, and the persons according to his requirement, the data or the value is displayed. So getting it? So whenever you go for any search anywhere, how do you go get those searches or document files or images? So all these applications are developed using this GIS server. So network-based GIS, what are those network-based GIS that we'll be using or we have to create is, first is web or internet GIS based server, next is enterprise GIS, then distributed GIS, mobile GIS, and many more. So all this GIS, whether we are talking about entrepreneur or mobile, they are all based on web-based. So enterprise GIS refers to geographical information system that integrates geographical data across multiple departments and serves the whole organization. Means if I am creating a database for my entire university, each and every department is independent in nature, but at last connected to Gyan Vihar University. So in the same way, if you want to complete or create any database for the entire organization, so means that each and every department will work independently, and then the entire database will be stored and will serve the entire organization purpose. The basic idea of entrepreneur or enterprise GIS is to deal with the departmental needs collectivity instead of individually. That collectively we want to see what is the requirement rather than having an individual request. I need a group request. For example, if I want to buy the number of table chairs for a university, I have to float a tender. So how would I get? Because I have to put an exact amount to that tender value, and then I'll redistribute to each and every department as per their requisition and the demand. So if there are five departments, and each and every department is asking, variation can be on the basis of their infrastructure demand, the subject. So the total requisition for us has come for near about 90 chairs. So I'll be putting a tender for 100 chairs. So means collective effort has to be done. So some of the potential bases and benefits of enterprise can be include significantly reduced redundancy of the data across the system. Means the repetition of the work what each and every department is doing will be reduced because the data sets is at a common platform. Like if there are 10 agencies working in any state, district, and all are creating the same land use land cover. So that is a wastage of time and money. Instead of creating the same database, you can put the database into the map server, and then according to their requirement, any operator or any service can use that data set. So that will provide a improved accuracy, the integrity, and the efficiency of sharing and use. Getting it?
Yes, sir.
Okay. Next is how does this enterprise GIS works? Like there will be a person, there will be a GIS software, there will be a hardware, then there will be editing and map, then CAD data will be used, hard and soft copy. Near about the entire thing, the only thing that has to be seen is the field data has to be collected, the made map, base maps has to be generated. The final output will be in the form of maps products that the user will be seeing. In between, what we'll be doing will be configuring it, and we'll be sharing it. We'll be doing the workflows, we'll be doing the production tools, we'll be doing the business rules, and finally all these data sets will be published using the web server to the users, where the users can fetch the data. Getting it? Now this is the most popular term and the most recent term that each and every person is talking about when you talk about GIS. They talk about, do you know web GIS? So what is the difference between a GIS and a web GIS? So the integration of GIS and internet technologies is allowing the GIS professional to solve one of the most important problem inhabiting information utility. Means many time, like if I'm doing any exercise in my laptop and I'm not sharing it, it is not into public domain. So what is the use of that data set? Because any research, any data set creation by any government or any research organization, or the purpose of studying is to get a good society, prepare good human beings, and that can be when you're putting this all data sets on the internet. Because right now each and every person, if you take out after 24 hours of a day, nearly 10 hours the person is giving, especially the persons who are students and housewives and the person who are staying at home. So how to provide and access to the information and the data without burdening end users with complicated and expensive software. Like the biggest challenge is key like Facebook or Twitter or Instagram. When you're creating an account, that is free of cost. But if I charge $10, if the Facebook charges or the Twitter charges $10 per month, the other month you will be looking for an alternative because that is free of cost. That's why and popular though there are other software social site softwares available in the market, but you're not using it because of their user interface, because of their popularity, because many of your friends are not in that connection. And that is because many times if you go, they'll ask for money, you have to pay $10 or $20 for lifetime. So these are the excessive burden that the company is putting to the individuals, and we the people generally want any system that is free of cost. So in the Google search also, whenever you're putting a search, you're not paying anything. But the day if the Google start asking that for every search you have to pay 10 paisa per search, so you will be very choosy in being searched. So that is all the logic that you have to see whenever you are putting your application into the web GIS portal ki how cheap it can be, how easy it can be to the user who is finally going to use your data and products for the benefit of the society. So internet is the best means of GIS data accessing, analyzing and transmission. So if the same thing, whatever database what I am creating and it's of international use or national use and it can benefit a large society, I can put my entire GIS database to those person who can use and can use for their development. So World Wide Web like www. FTP. Generally, you are downloading the data sets from USGS, Glovis, their GLCF. The data sets are uploaded, and here, if you go to the tool through which you can download is FTP. So, what is that FTP? FTP stands for File Transfer Protocol. File transfer protocol. The entire data set is saved, and using the cloud service or whatever service that the provider has taken into, the data is transferred to the user. User are we students, it can be a scientist, it can be a professor, it can be an NGO person, and all those data sets are transferred. And finally, HTTP, whatever you are trying to open a file that makes it convenient to access and transfer data across the internet. So these three formats makes the data very easy to travel from one corner to different corner of the world. So internet, but for that internet is required, and the internet provides GIS user easy access to acquire GIS data from diversified data source in distributed environment. So if you have created a portal and all the things in his GIS environment, so anybody right now, if we are doing work from home, for example, I'm sitting in Rajasthan, somebody from Himachal, somebody from Mumbai, somebody. So if they are creating the data sets independently, how will a company provide them a salary if their works or the client's objective or the purpose or the demand or the architecture what they have suggested or given has not been incorporated? So for that, there is a server portal where each and every data is assigned to a person, and he saves the data into that server portal, so that I can also see what Ramesh is doing at Himachal, because his data has to be taken as an input into the my data. So that is a 2 or 3 way process where each and every individual is connected, where the client is connected, who is getting the final output, then the company is connected, who has been given that tender, then you are connected, then your managers are connected. So all this connection can be done only if you are providing this through a server to a common distributed system. So GIS user can use and download the data by sending the request through web browser application. So anybody, so nowadays you can see that whenever you're going for any web application, there is a login and password being asked. First you create, you register yourself into a particular, whether it's Bhuvan, USGS, Glovis. First it's created, your entire database is checked, your IP is checked, what is your purpose. Then they continuously monitor your system, server, your applications, the server provider, what kind of application you are going to use it. So there is lot of things that we have already said about GIS. Now we should know what are the properties, because each and every portion has got a property. So in the same way, WebGIS has also got its own property. They are very basics in nature. So WebGIS is dynamic, means that is not static. If I multiple users are there, multiple entries are going, updation is going. So that is not a static. Static is the data that you are keeping in your system. That is static, means you are only the user, you are the only the person who is working on it. So that is not dynamic, that is not changing. But when you put in the waves, it's very dynamic. For example, once any client or database administrator updates the data or information at the server end, it will be available for all clients on web at the same time. Means if I'm putting the entire information, as I have already stated, that the entire portions are connected in that web interface. So whatever connection or whatever update what I am doing in my databases will be parallelly seeing to each other and can be parallelly used using this web GIS technology. So the internet GIS can link the real-time information such as satellite images, traffic movements, accident information by real-time connection with relevant information resources. So many times you will be seeing that when you are moving through Google and you want to see, it will be saying you where there is a huge red color, huge traffic congestion, then orange color, it's intermediate and rest. So how does those information is created? Those information are created using internet GIS. Like if you are passing through, there will be a information coming up, you'll be feeding those information that I am stuck up for last half an hour. And for me, like me, there are various users who are passing through and they are updating the data set. So what you will be do, you will be looking for an alternative route, or you will be saying it has been more than 2 hours. You'll put a feedback, and that feedback directly goes and is connected to the internet, and through that internet it will be directly updated in the form of signals, in the form of colors, in the form of information, in the form of symbols. That many times you will see there is a road construction going on, so there will be a symbol coming up that you have to take another. So that is the real time information that can be generated using the use of WebGIS. Then the application developed are cross platform and accessible through any web browser. Means they are independent of the web browser platforms. Whether you can go, you can use Google Chrome, you can have any Opera, you can have Internet Explorer, you can have Mozilla. So you can use any of the platforms, and it's cross platform. It is not that you have to use only a particular Google Chrome or Opera. And finally, the Internet GIS application can be categorized into two categories. If I am trying to say about WebGIS, there will be a two category. One is server side application, other one is client side application. To make it more easy to understand, one is server side and other one is client side application. So what does server side application means? Server side applications rely on GIS server. GIS server means there will be a GIS server, usually reside on a remote server. It will be into some interior areas to perform all GIS analysis, because costing is also involved. So if you are going to any shop, you know what is the amount of money you have in your pocket. So there are shoes that ranges from 1000 to 1 lakh rupees. So depending your objective and application and cost, You have to perform those analysis, while the client size application perform GIS analysis and processing in the web browser on user's local machine. Getting it?
Yes, sir.
So, a typical web client server model, how it is. See, you've got a web browser, you've got the database file, you've got a web server that you have corrected, and in between you have got URL request, whether you are going for www dot or HTML or the images. So this all are connected using web server, and we'll be using through web browser. That is, web browser is your Google and or web server where the data is saved and all this database files. And this is the typical web mapping model. So what you have to do is, there will be a GIS gateway where you will be having the GIS database and GIS software, where the web server, on the basis of your spatial request, whether that is a spatial data or non-spatial data, the web browsers need a plugin, especially the plugin that is being ActiveX or Java applet, that is being used for creation of this database for server GIS, so that the entire database can be connected to each other. So if you are talking about full GIS servers as imaging, so you can see that there is a two kind of server that we have to be dealing with. One is GIS based server that deals with the mapping and visualization, that deals with the data services, that deals with the editing. Thereafter, we'll be requiring a geo processing services, we'll be requiring a catalog catalog services, and all this will be included as a standard web services, because at last what we are trying to work on, we are trying to work a standard based cross platform and IT focus. So whatever this database or the methodology that you have been seen, we are trying to correlate our geo relational database management system. So if you do remember that we have already studied the various kinds of data management system and their types. So here we'll be using the RDBMS in order to get a XCML standard and distributed computing, so that all the data sets can be fetched, can be seen using open platform. Now, what are the basic requirements for the components of web development for GIS or web GIS? The components or the server end, what we are requiring? We are requiring an operating system. Then in the operating system, we will, the type is software. Then the other requirement is Microsoft or Linux is required. The vendor, they provide this operating system, because if you go for operating system, who is providing it? We are using Microsoft or we are using Linux, and it can be a freeware or it can be a commercial. Then second is map or GIS. Please mute your mic. Please mute your mic. Whoever is, please mute it. Then you need a map or GIS server. Map or GIS server. So who will be providing this GIS server or the map server? It will be provided with ESRI or ADAS or Intergraph or Rolta or Microsoft. Again, it can be a commercial or it can be a freeware. Then after map server or GIS server, the other important feed is web server. We need a web server through which we'll be using it. And for that, we will be using Microsoft IIS or Apache web server. It can be commercial, it can be freeware. So now we have done with our four component, that is operating system. Now we have got a GIS server where we'll be saving all our data sets. Then we have got and the software for processing it. Then we have got web server where all the web related information and the questionnaire will be saved in. Then we need a data server where all the data will be saved with, and that will be saved by the service provider. It can be Google, it can be IBM, it can be MySQL, SQL server, both. It can be commercial, it can be freeware. Then there is a optional thing that is required. Hello.
Yes, sir.
Then there is a, can you see?
Yes, sir.
Then a spatial database management system, optional. That is optional, that is not prerequisite. It's and this all are the data sets that we are talking about the server side, because now you know there are two kinds of side. One is your server service side, other was is client side. So special data sets, then you need programming languages. It can be a software that is Microsoft .nlp or ASP or Sun or Java. Again, it can be a commercial or freeware. Then you need a internet connection, because without internet connection, this web data and the data sets cannot be interconnected with each other. So that can be a commercial, or that can be a freeware. Again, you need a domain, because without domain you cannot work and you cannot have the data sets that can be floated into the server. So again, that requires networking, and again that requires pricing. So this is the entire architecture that is required at the server end. Getting it? You need operating system, you need a GIS server, you need a web server, you need a data server, you need a special data management software, you need a programming language, you need internet connection, you need domain, and at last the client end, with the means the user end need only web browser. It can be Microsoft, it can be next scale. So for today, I think that this is the last thing that we'll be taking up, and 1 minute of uh, or 2 minutes of discussion. If anybody has got any question, if not, then we can just close the class. Anybody?
No,
It's
sir,
all
but
okay.
yes, sir.
All okay, under control, understood.
Yes, sir.
Okay, then we'll be doing some practicals related to this in our coming classes. And with this, I end my today lecture on WebGIS and its application.
Yes, okay,
Okay,
sir.
so what I have to do first, I have to recording, I have to stop recording, stop recording.